Okay, so this video is on ionic and covalent naming, formula writing, and how to tell the difference between them. Alright, so an ionic compound is when we have a metal and a nonmetal bonded together, and that bonding happens because there's a transfer of an electron, or more than one electron. One substance gives up their electrons and the other one takes them. And so that's what makes something ionic, versus a covalent compound is two nonmetals, and that involves the sharing of electrons. So a very famous ionic compound, for an example, is sodium chloride. It's very easy to recognize that it's ionic because it has the sodium, which is the metal, and chlorine, which is the nonmetal. Very famous covalent compound is water, and very easy to tell that it's covalent because both its elements are nonmetals, the hydrogen and the oxygen. Okay, so that's looking at them, how we can tell if something is ionic or covalent. All right, so from here is a discussion of how do we write formulas. We'll do ionic first. So how do we write a formula for an ionic compound? If you come across the name, so let's say we come across calcium fluoride. Okay, so because it's ionic, the root word is ion, and so we are interested in the ionic charges when these atoms become ions. So we go to the table, we look at their charges, and the goal is to get these charges to add up to 0. So they have to cancel each other out. Same amount of positives as negatives, so the whole compound is neutral. So if we look at calcium, when calcium becomes an ion, its charge is +2 because it loses 2 electrons. And fluoride, that's fluorine, and fluorine has a charge of -1. So if we look at this, we have a +2 and a -1. I need to get those charges to add up to 0. Right now they don't. The only way to do that is to add another fluorine, and this gives me a compound now of CaF2 because I have 1 calcium and 2 fluorines, and so this is my formula for calcium fluoride. Now some of you may have learned what I like to call the crisscross method, and that will work. It's perfectly fine. It's not how I teach it, but it's perfectly fine to do it. So in the crisscross method, you still write your charges, but you pull this charge down and that becomes the subscript, and you pull this charge down and that becomes the subscript. So you're still left with a formula of CaF2. So the crisscross method does in fact work every time. Let's do another example. We'll do one with a polyatomic. So ionic compounds are the only compound that's going to have polyatomics, and polyatomics are most easily recognized by their names. They end in ate or an ite. So if you see an ate or an ite, it's most likely a polyatomic ion. So let's do one. How about aluminum sulfate? Okay, so right away we recognize the 8. This thing is going to contain a polyatomic. It's not located on your table. It's one of these memorizers. Same deal though, we balance charges. So if I look up aluminum's charge is +3. It becomes a cation by losing 3 electrons. Sulfate is SO4. Whole thing has a charge of -2. So if you're doing, if you're writing a formula charge balancing, like the way I teach it, I have this +3 and -2, and my goal is to get those numbers up to 6. It's the least common multiple. And to do that, I would need 2 aluminums total, giving me a +6 charge, and I would need a total of 3 sulfates, giving me a -2, -2, -2, which is -6. +6, -6 cancel out, and I'm left with Al2 of them, but I have 3 SO4s. And the only way to tell me that is to put them in parentheses. So here's my aluminum sulfate compound. Notice that there's no indication that I have 2 aluminums and 3 sulfates from the name. So ionics can be a little bit tricky. Again, your crisscross method will work here perfectly fine. So just super quickly, if you're doing crisscross, you pull the 3 down here, you pull the 2 down here, and you're left with Al2, SO4, 3, and you get the same formula. So there you go. Only thing I haven't talked about is transition metals in ionic compounds. And transition metals are the metals in the middle of the table, which don't exactly follow our rule for for losing electrons. So let's say I come across this name, and I need to write a formula. So notice it has Roman numerals. We haven't seen that yet in this video. And that Roman numeral is trying to tell you the charge of copper, since copper can flip-flop and be more than one charge. So copper is a metal, so his charge is definitely going to be positive, but the Roman numeral is telling me that his charge is a positive 2. So Cu plus 2, chloride is chlorine. Cl minus 1, I need another chlorine, or again, if you're crisscrossing and your formula is CuCl2, notice no Roman numerals in the formula, but I had to have that Roman numeral up here with the name, or I would not have known the charge. So that's pretty much it for ionic formula writing. Let's go through a couple naming ionics super quickly. Let me come up with a couple. Oops. Let's see. And so, okay. So let's say I have these 3 formulas and I'm looking to name them. These are all ionic. Notice metal, metal, metal. If that first one's a metal, it's ionic. So the way to name ionics is just fairly simple. You name the first thing, which is your metal, straightforward. So this is aluminum. This is calcium. And this is copper. So no trick there, just naming the metal. And then to name the anion, or the negative one, all you do is you change its ending to "ide." So this is oxygen, and that becomes oxide. And so that first one is done. Aluminum oxide is its name. Again, notice that the name has no indication of the 2 aluminums and the 3 oxygens. Okay, the name has no indication of how many atoms are in the formula. If I go down to the next one, I've already named calcium. Now this is a polyatomic. Okay, so we don't separate it, we name it as a polyatomic, and that is sulfate. And with the polyatomics, their ending does not get changed, so I leave it as 8. So calcium sulfate. And then the third one, I've already named copper. Again, this is a polyatomic, and this is phosphate. So I leave that ending as 8. I don't change it. Copper phosphate. Except that copper is a transition metal, so your light bulb should be blinking to tell you that you need something in this case, and you're going to need a set of parentheses with a charge. You need to indicate the charge on the copper. So I teach it this way. If you're going to pull copper's charge out of this, I draw a picture until you get good. And there's 3 coppers. I'm going to jump up here. So 3 coppers. Okay, we know they're positive because it's the metal. And there are 2 phosphates. And phosphate has a -3 charge. Gives me a total charge of -6, which means my positive charge has to be 6 to cancel out. And that means each of these coppers has to be +2. So the 2 is what's going to go down here in the parentheses. And this is copper 2 phosphate. I'll show you the other way, the crisscross way to pull the charge out. Actually, it might be simpler. So the crisscross method to pull the charge out of the formula would look like this. And that's where those subscripts become the charges. So you pull, that up here, that guy was -3, and you pull this up here, and that guy was +2. And that's as simple as it is to pull the charge out of this situation. So crisscross method here works a little bit better. All right, so that was ionic. Naming and formula writing. We'll do covalent, which is much simpler. So again, covalent, 2 nonmetals, no ions. I don't have to deal with any of those charges or charge balancing or anything. The big thing with covalent is your set of prefixes. Okay, and the prefixes, there are prefixes for the numbers 1 through 10. Prefix for 1 is mono, for 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Okay, those need to be memorized. They're not super difficult. They are pretty easy. So there they are. Make sure you have them written down. So in covalent, we use prefixes. And the rules for naming go like this. I'll put a couple up here. All right, so covalent naming goes like this. You name the first atom as is, and you use a prefix in front of it if there are more than one atom. So in this case, I have 2 hydrogens, so that means I'm going to use a prefix. The prefix for 2 is di. So di, and then I name this guy hydrogen. Okay, for this one, I only have 1 carbon, so I do not need a prefix. Remember, the rule is use a prefix on the first atom only if there's more than 1, so I'm just going to name this as carbon. And then again here there's 2, so I need a prefix, di, and that's sulfur, so disulfur. And then to name that second atom, you always use a prefix regardless of how many there are. So in this case, there's only 1 O, so the prefix for 1 is mono, so that comes in front, and you change the ending to "ide", so monoxide or monoxide. And this guy's name is dihydrogen monoxide. Again, same thing here. There's 2 oxygens, so prefix for 2 is di, so dioxide, and of course that's carbon dioxide. And then for this one, there are 3 oxygens. Prefix for 3 is tri, and this would be trioxide. So that's naming. Quite simple. No tricks. The only thing you have to remember is you don't need a prefix on the first one if there's only 1 of them. And then the easiest part of all is writing formulas for covalent. So do a couple examples and then that's it. Okay, so there's no charge balancing needed, and in these ones all we have to do is think about what the prefixes mean and how many atoms we have. So noticing that there's no prefix here on carbon, that means I only have 1, and monoxide means I have 1 oxygen, so CO is your formula for carbon monoxide. In the second example, no prefix on sulfur means I only have 1, so S. Hexa means 6, fluoride, 6 fluorines, sorry, so SF6 is my formula, and that is covalent formula writing. Very simple, no charges, and that will end this video.